So today we're going to be talking about exponents. So in an exponent, you have the base, which is a, an integer, a decimal, or a fraction, and you have the exponent n, which is any counting number. So it's written like this. And an important thing to note in an is when you multiply a by itself for like n times, then you can end up with a to the n. So there are a lot of properties for exponents. So the first one is that if you have any number, a to the 0th power, it's equal to 1. However, a cannot be 0 because 0 to the 0 is not 1. It's undefined. So a to the 1 is equal to a, which means that any number, including 0 for this one, is equal to itself when raised to the 1st power. And if you have a base a and it's a to the m times a to the n, you want to add together the exponents and keep the base. However, if you want to add together a to the m and a to the n, you cannot say it's a to the m plus n. This only works when you're multiplying these two. If you want to divide, say you have a to the m over a to the n. Again, the base is the same for both of them, but the exponent is different. You just have a to the m minus n. And if you have a to the m raised to the nth power, you can just multiply together the exponents to get a to the m times n. And if you have two numbers here that you're multiplying inside the parentheses and you're raising this to the nth power, this is just a to the n times b to the n. Here, if you have the same exponent but different bases and it's in a fraction, say a to the m over b to the m, you can take out the m here, and you can also vice versa. And if you're working with negative exponents, you can just take the reciprocal of the positive exponent, which means for a to the negative n, you can just do 1 over a to the n. And for here, you can say that a to the m over n is the same as a to the 1 over n to the m because of rule 5. You see, you're multiplying this by this, and you're getting this. So, in order to solve exponential equations involving exponents, some helpful knowledge is that if you have a to the m is equal to a to the n, this is true if and only if n is equal to m, and all the variables here are constants. So here you have two pretty scary looking equations. They're both quadratics equal to 1. But the trick here is you only really need to worry about one of them at a time. So the first case is that this here is 1, and you know that 1 to any power is 1. So you can just ignore this. Or you could say this is equal to 0. You could solve for that because you know that anything to the 0th power is 1. But 0 to the 0 is not 1. So you have to make sure this isn't 0. And the third case is if this is negative 1 and this is even. And this works because negative 1 to any even power is 1. And so here you have this equation fx to the gx is equal to fx to the fx. So again, one way you can solve this is if fx is equal to 1, because 1 to any power, again, is still 1. For case 2, you can solve for gx is equal to fx, because again, if you have the same base and the exponents are also the same, then this is equal. And lastly, if fx is equal to negative 1 and gx minus fx is even, this also works, because if gx minus fx are even, these are either both odd or both even. If they're both odd, this will all come out to be, both of these will come out to be negative 1, and if they're both even, these will both come out to be 1, so they'll all be equal. So if you want to compare exponents, you can see here that if a is greater than b and both of these are greater than 0 and c is a positive real number, then a to the c will always be greater than b to the c, but a to the negative c is always less than b to the negative c. If a is greater than 1 and c is greater than 0, then a to the cth power is greater than 1. And if a lies between 0 and 1 here, and c is greater than 0, then a to the c is, again, between 1 and 0. And if a is greater than 1 and c is greater than d, then a to the c is always greater than a to the d. And if a is between 0 and 1 and c is greater than d, then a to the c is less than a to the d. So there's definitely a lot of equations and stuff that you want to memorize and get familiar with exponents, but if you just practice them, they'll get much easier over time.